All right, hope everybody's enjoying day one of the YOW conference for 2025, as mentioned by Ted. My name is Conor Hoekstra, and thank you for mentioning my YouTube channel. I was at the last conference in Melbourne, and someone came up to me afterwards, and they said, "Are you the YouTube guy?" And I was like, "Hi, did I forget to mention that?" So thank you for mentioning that. It'll be covered in a sec. Welcome to my talk, Enter the Matrix. We're going to talk about a number of different things today, and I'll get to that in a moment. But there's a QR code in the top left hand of the screen. This is a tiny URL that you can go to, and this will bring you to my Linktree/About Me, which I'm about to show in a second. And I'll show this at the end of the talk too, in case you miss it. So this is my quick about me. Name is Conor Hoekstra, as mentioned. I also go by Code Report across the socials and on YouTube. So you might know me better by that if you know me at all. I work at NVIDIA as a research scientist, so I work on array programming models and libraries. And I have expertise in algorithms and another thing called combinatory logic, which we might talk about a little bit today. As mentioned as well previously, I have 3 different software podcasts. The main one, let's see if this works. I vibe coded this. Look at that. We got little stats here. So the main one is ADSP, stands for Algorithms plus Data Structures equals Programs, borrowed from the famous Nicholas Wirth book. We're up to 264 episodes as of last Friday. That's been going for 5 years straight. We've never missed a week. And we just crossed the 1 million download mark a couple months ago. My YouTube channel I started even before that. I think I'm close to 400 videos. So you can see a couple thumbnails here. The more popular videos that I make are the 24 programming languages, one problem, where I tackle a single problem in a bunch of different programming languages across a variety of paradigms and compare and contrast. Why is this better? And spoiler, it's usually the array languages that I say are the best. Anyway, we'll talk about that in a sec. And I've also given conference talks across many conferences, typically the C++ circuit, a little bit the functional programming circuit. But this is first time in Australia, first time at YOW, and I'm super excited to be here. I've watched some YOW talks dating all the way back to like 2012, just on YouTube. One of my favorites is by Dave Thomas. So if you're interested, I can pass that link along after this talk. So this QR code is going to bring you to this slide deck. The lighting's pretty good on here, and if you're watching this on YouTube, hello, leave a comment down below. But in case you're at the back and you can't make stuff out, you can follow this to a interactive version of this talk. I'd please ask, if you're doing this on your phone or your laptop, though, mute, because there are a couple of videos that I think are going to autoplay. So if you're following it along, we might get duplicate audios if you don't mute. So. Also, if you're not trying to get to that talk via the QR code because you don't know how to do that, you can also follow in the bottom left. It says conference talks and content. That's a README of a GitHub repo that has slide decks for every single talk that I've given in the past. So if you go to YOW 2025, you can also get to it that way. So that brings us to the talk entitled Enter the Matrix. So this is going to be matrix themed, and we're going to primarily talk about 3 different programming paradigms today. So the first and the most important, in my opinion, in 2025 is AI programming. Initially, this used to say AI-assisted programming, but if you are following along with the releases of the latest models, Gemini 3 and Claude 4.5 Opus are unbelievable, and at this point, they're barely assisting, they're almost doing it all. And a part of the goal of this talk is to hopefully reset your expectations for what these tools are capable of, and reset them not down, but upwards. So whatever you think it's good for now, hopefully by the end of this talk, you'll think, maybe I should reassess what I'm using these tools for. The 2 other paradigms we're going to cover are the array programming paradigm, which we'll get to later, and then also GPU programming. I work for NVIDIA, and so a part of our mission is to make targeting and accessing the compute and accelerated compute that NVIDIA hardware give you a lot easier, because it is difficult if you've ever done any CUDA programming, whether that's in C++ or in some of the Python DSL dialects. It's not always that easy. So. Question, who, and keep your hands raised because I've got a couple questions, who at any point in the past has used an AI-assisted tool, an LLM specifically for generating code or doing something code related? So raise your hand and keep it raising. All right, so I think every single hand, maybe a couple haven't gone up. I'm not sure what's going on there. You should take it for a spin. So keep your hand raised if you agree with the following statement. I use them on a daily basis, Monday to Friday for work. So we're down to about 80%, maybe 90%. All right, so keep your hand raising if you also agree with the following statement. Like, I never want to go back. I can't live without these tools for my work. All right, now I think that was maybe another 10% that dropped. So now we're down to about 70, maybe 60. It's hard to estimate. So you can drop your hands now. So that is my personal take. I absolutely love these tools. They have completely changed the way that I work. At a minimum, in my opinion, these do all of the typing for you. So I historically have been a CUDA C++, C++ expert. I have a theory that depending on the niceness of your ecosystem and your tooling related to your programming language, your threshold for liking these tools varies. If you are in a really nice ecosystem like Rust or Ruby, you might not like these models, or you're not as likely to like them. In C++, I spend my whole day fighting with the compiler, syntax errors. If I can get a tool that's going to automatically do it correctly, it's fantastic. So, I'm trying to pitch, take the red pill. You gotta give these tools a shot, and you'll be amazed at what they can do for you. This is just to kind of put my bias out there. We released a few months ago a series of 3 episodes, High on AI, Part 1 and Part 2, where I chatted with my fellow coworker, Bryce, who's one of my podcast co-hosts, where we basically gush over 2 episodes for 2 hours talking about how amazing these tools are. That being said, I have another co-host, Ben Dean. He works at Intel, and he's not a huge fan of these tools. And at the time, I don't think 4.0 for Claude had dropped. There's a lot of issues with them. And so anyways, I love chatting with folks, whether you are pro or anti, or you've had a good experience or a bad experience. But just know that I am very, very pro all these tools. Some would call me an AI maximalist. So in my opinion, you've probably heard of at least vibe coding, but there are 3 different types of AI or AI-assisted coding. Vibe coding was termed by Andre Karpathy. If you haven't heard of him, look him up online. Find everything that he has via podcasts and YouTube. I think he's a great person to follow in the year of 2025. And the other 2 that you may not have heard of, I've kind of coined these terms, are guide coding and rage coding. Rage coding, admittedly, doesn't exist as often as it used to. So if you've ever used the Anthropic Claude models when it was the age of 3.5, which was the tail end of 2024, up to the first 2 to 3 months of 2025 until 3.7 came out, you could get to interactions with these tools where they would just gaslight you. You'd say, hey, could you implement this? I've got some unit tests. They'd iterate a little bit, and they'd come back to you and say, hey, it's working, and you go take a look, and they've just deleted all your unit tests. And obviously, that's not what you want, so you ask it, that doesn't count. You can't delete the unit tests. And then they go delete all your code, and you'd be like, it's just a terrible experience. That's rage coding. It's very, very frustrating. The worst case is when it's telling you something and it's convinced that it is done something, that it's done something different. Anyways, a very negative experience. Now with the latest models, this rarely happens to me. And honestly, when it does happen, it's because I've made a mistake. The other day, I had 2 cursor instances open, and I accidentally continued to chat from one and the other, and it started doing some weird stuff. And I said, why are you doing this? That's not what I asked. Like, you should know better at this point. And then I realized, oh, I'm in the wrong instance of cursor. It is my fault, not the AI's fault. So anyways, rage coding, it's when it's not going well. But guide coding is how I actually do most of my coding, especially for work. When I'm vibe coding, it's typically for stuff that's personal project. It's software that's not going to see the light of day. It's just for me personally. But for work, I have to ship this stuff. We're going to open source stuff. You really need to make sure that the quality and the unit tests and everything that you're doing is like 100% good. So guide coding is when you're holding the hand of these LLMs and you're constantly reviewing every single line of code. I use it for everything. It's still typing all my unit tests, all the implementations, but I am, very closely watching what it's doing. And at any point it takes a wrong turn, you're basically course correcting for the LLM. And I think, people always talk about vibe coding, and then there's a lot of criticisms of that, the quality of the code, etc. But you can use these tools in a way that is basically the same way that you would code. It's just accelerating the speed at which you can get tasks done because you don't have to type stuff, which is fantastic. So this brings me to my tips for AI coding. Number 1 is, and raise of hands, who uses a IDE or a CLI app, meaning that the way you use the tools is not just going to ChatGPT in a web interface. You're using like an IDE or a terminal-based thing. Raise of hands. Okay, so that looks like 75% of the room. If you're in the 25% of the room that either hasn't tried these or is just going to the web interface, you need to take, or you don't need to, I implore you to try to, these tools out. So Cursor is what I personally recommend. I've been using Cursor even before, so now most companies, they pay for these tools and the subscriptions for their employees. I was using Cursor before NVIDIA was paying for it because I thought it was, such a force multiplier in terms of my productivity. Anti-gravity is a great new addition. It just dropped with Gemini 3 from Google. If you haven't taken that for a spin, it's not as good as Cursor in my opinion, but if you're doing anything that's basically browser-based, anti-gravity, the main difference between Cursor and anti-gravity is because it's out of Google, it has a really, really good, basically headless, browser, incorporated into the IDE. So many times you'll be in the chat window, you ask for something, and it'll launch a browser and then start navigating, and it'll ask you questions interactively. So if you're ever trying to do some scraping or beautiful soup or Selenium thing, anti-gravity is fantastic for that stuff. So the main point being here is if you're just in a web browser asking questions, copying and pasting, you got to give these iterative tools that are, checking the unit test before they get back to you and say they're done, because that is the best way to do things. So point number 2, use the latest models and always be trying the latest models. I talked to a lot of folks that say, I tried it a year ago when it was on Claude 3.5 and it was just a terrible experience. It is vastly different now than compared to when Claude 3.5 out. We're like 3.7, 4.0, 4.1, and 4.5 now. I believe the next slide. So there's a bunch of these sites. This is not LLM Arena. This is like our Artificial Intelligence Index. The nice thing is if you go to the website for this, you can hover over each of the little boxes and it'll tell you which model was released. And so it's showing here Anthropic, which are the Claude models, Google, which are the Gemini models, and OpenAI, which are the GPT models. You can see basically back in March of 2025, that's when 3.7 Claude was released. So there was a huge jump from 3.5 to 3.7. And you can see now the 3 at the end are Gemini 3, GPT 5.1, and I believe Claude 4.5 Opus. These models they're just insane. If you haven't taken them from a spin, I would implore you to. And that's one of the nice things about Cursor. As soon as these models drop, literally an hour later, they are available in Cursor. And as soon as you open a new instance of Cursor, they're going to ask you, there's an update available. Would you like to download it? So using these tools, I'm not sure if anti-gravity has that feature, but you can basically try these models up and there's a little combo box that you can switch between them all the time. My personal preference is the Claude models. This technically is not measuring coding ability. It's measuring overall intelligence. So you can see that they're actually all quite close to each other. But if there was a coding version of this, I think the Claude 4.5 and Gemini would be slightly above the OpenAI GPT models in my personal experience. And dating back to when Claude 3.5 and 3.7 were out, it was kind of unanimously agreed upon in the industry that Anthropic was investing more money in the Claude models, so they were the best to use. And I see a bunch of folks nodding in the audience. So back to the tips for AI coding. Be clear about your confidence level. So one of the tricks that I realized early on that I kind of implicitly learned that I was doing, but didn't realize that I was doing it until I talked to a senior engineer at Adobe on the ADSP podcast, was that you have to be clear about how confident you are in the solution that you're asking for or proposing. If you don't know if something is a good idea and you just ask a model to do it, it'll try and do it, regardless of whether it's a good idea. These models are not smart enough yet to stop when you've asked for something and say, do you really want to do this, or would you like to try this that is actually the better way to do this? If you really know what you want and you know exactly the form, the language, the library, the way you want the library used, explain all of that, because the models are very, very good when you give it the specific shape of what you want, of giving that to you. If you're not sure if it's a good idea, literally put that in the prompt. Say, I would like X and I'm not exactly sure what the best path. Can you give me 3 or 4 different suggestions and the pros and cons of why one is better than the other? And then you can just basically, as you would with a colleague, go back and forth and say, actually, I didn't realize these would be the differences, but option 3 is the best because of that. So if you're not sure, bake that into your prompt. And that kind of dovetails into the next point, which is the more detail, the better. The way that I actually use these models when I work remotely at home, so I have a little office, is even before they had Cursor for a long time, didn't have the speech to text built into it. I had vibe coded my own app that would basically use the Whisper models in Python, speech to text in that app. It would copy it to my clipboard. So I basically just have a conversation with myself, copy it, paste it into Cursor, and then I'm off to the races, because you can kind of ramble and give more detail than you might if you were just typing. And the models are better. The more information and the more specific you are about what you want, they're better at, giving you what you want because you've basically overspecified. Overspecifying a lot of the times with these models are a really good idea. The second last point, same with kind of rage coding, doesn't really apply as much anymore, but back in the day, liberally restarting chats if you were going down a rabbit hole that wasn't giving you what you wanted, just restart, It's kind of the classic, IT, what's the best solution? Just, hit the power button and restart it. Also worked with chats. These days, honestly, I very rarely restart unless if I'm switching to a whole new task because as these, the contexts grow, they're constantly compressing the conversation and the context that you've had in that prompt, and that's helpful for future questions that you're giving to these models. And last but not least, always be experimenting with the newest models and tools. Like even if you love Cursor, or if you love some CLI app or Claude Code, if there's some new tool that comes out, it's a good idea just to know, the differences. Do I like this? Do I not like this? I have basically religiously used Claude up until Gemini 3. And when Gemini 3 dropped, there was a number of I have these internal tests that I see how good are these models. And Gemini 3 absolutely crushed what it had been struggling with. It would only hit the 25% mark of success. It went and hit 100. And I was like, holy smokes, we've entered a new phase of these models. So we're now hopefully going to watch a couple clips. And the first one, I imagine, raise of hands. Actually, raise of hands if you haven't seen The Matrix. There is at least one hand. Homework for after this conference. Maybe not tonight, but go give The Matrix a watch. But this is when Morpheus is fighting Neo.
Understand. Then hit me, if you can.
Good. Adaptation, improvisation. But your weakness is not your technique.
Morpheus is fighting Neo.
So, unfortunately, this is a 5-minute clip, and this is only a 45-minute talk. I'd love to watch the whole thing, but we don't have time. But I love this clip. First of all, I think it's one of the most iconic clips in cinema. I've probably seen it 200 times in my lifetime. You can find the link on YouTube. But this is kind of how I felt when I first started using Cursor. It was I downloaded a bunch of info into my brain that I didn't have, and I was off to the races, and here we go. But then, what ends up happening? At the 75% mark of this fight, Neo's losing. And then Morpheus asks him, why do you think it is that I'm beating you? And Neo says, wow, you're stronger than me. And he says, do you think my strength has anything to do with the matrix that we're in right now? And he goes on to say,
You think that's air you're breathing now? Again.
And that is the philosophy that you should internalize. We're no longer breathing air. We're in this new world. And literally a couple seconds later, like I said, I'd love to watch the whole clip, but he goes on to say,
don't think you are. Know you are.
And the version for LLMs and, Google CLI and Cursor is don't think you can, know you can. A lot of people, they try these tools and they give it one shot. It didn't do what I wanted. You're not giving it a fair shot. Don't think it can do what you want it to do. Know it can do what you want to do. And that brings us to a little demo that I've basically worked on for this presentation. So I have entirely vibe coded the application that you're about to see. It's called Blink. And this is actually a reincarnation of a program that I wrote 13 years ago in 2012 that was called Metric 6 at the time. And I built it in ActionScript 3.0. If you're familiar with that language, it's the language behind Flash. Rest in peace, Flash. And this was before I knew how to basically code. I mean, I'd taken a Python course and a Java course, and I was still in school, but the code, it'll never see the light of day. It was for loops and if statements, but I wanted to be a quant at the time, and so I built this kind of technical stock screening program. So very quickly, there's a couple features. The reason I'm showing it to you is because this was the inspiration for what I'm about to show you. So this was blue mode. We switched between OHLC, which is the candlestick, so open, high, low, close, the data points that form the candles, the ability to like drag and drop, zoom. And so the point being is that I actually built this 13 years ago and have always wanted like a newer version that I could extend, which you're going to see in a bit. So the point being is let us show this little demo if I've got it correctly here. So this is now Blink, the reincarnation of metric 6. So the nice thing about this is that everything is shortcut driven. So I used to be an actuary. I love Excel, and I was the kind of Excel power user that would never touch their mouse, you know, and the same thing if Vim, Emacs, same idea. But so these are all the shortcuts. I'm not going to go through them one by one, but you know, the H toggles, and so typically toggling is the way. So by default, you're in candlestick mode, but if you hit B, you go to blue mode. And so, you know, this is where we're getting rid of the candlestick because sometimes you don't want all that extra information. If I hit T, it toggles off the simple moving averages and Bollinger Bands. If I hit M, it's going to give you a comparison to the S&P 500 because, you know, sometimes you're looking at a stock that, you know, is very, very nice. It's going up a lot, but if it's below the market, you know, it's actually not that great. It's just underperforming the market. So we can go back from blue mode to the candlestick mode. And there's a bunch of other features. You know, you can do the same kind of drag and drop, the same stuff that we used to do. By default, it's set to the 6-month mode, but if you toggle between 1, 2, 3, and 4, that's the 3-month, 6-month, 1 year, and 5 year, you know, views, and it's fantastic. You know, this program it makes me very, very happy, and I use it on a daily basis, you know, to monitor. And you can see that there's a ticker list on the right hand side of the screen. This is the Meg 7 stocks. You know, it used to be what did they call it back in the day? It was Manga, and before it was Manga, it was Fang. Anyways, they're always coming up with new acronyms. The current one is Meg 7, so, you know, it's a bunch of companies. I actually heard on a podcast that it's now the Meg 6 because Tesla was not doing that well, so they weren't magnificent enough to be in the Meg 7, but that didn't catch on. So it's still the Meg 7. Anyways, this is Blink, and it's pretty fantastic. So what's amazing about this, entirely vibe coded. Written in JavaScript. I don't know JavaScript. I've never looked at any of the code behind this, and some people might say, well, how do you know it's doing the right thing? Are there bugs? It doesn't matter. I can visually verify that this is what I want. If it's not doing things the way that I would have programmed it, does it actually matter at the end of the day? I'm not shipping this software anywhere. This is a personal program for myself that I know. And like, there's ways of verifying that it actually is displaying the data correctly that I'll show in a bit. But the point being is like, I've never looked at any of the code for this. It is like magic. I've got fairy dust in my hand and I blow it onto the screen. And it's just magical. On top of that, at one point when I first started writing this, I wrote it in Rust. Because I'm a C++ developer, and I like Rust better than C++, but you know, I don't get paid to code in Rust, so you know, that is what it is. But I think Rust is a better, you know, systems language than C++ is. So that's how I started this project. But at a certain point, I was making use of a library called Iced. It's used by a bunch of companies that are doing this kind of dashboard stuff. But it wasn't working great. And so I was at about the 2,000, 3,000 line of code point, and I thought to myself, why am I doing this in Rust? Like I kind of wanted to do it in Rust because I thought that would be the best language for this kind of app. And then I thought to myself, is it possible just to switch? So at the time I was using Cursor 3.7 and I just said, hey, I've got this system using Cargo written in Rust. It's about 2,000 lines. Can you just port the whole thing to JavaScript? It spun for 5 minutes and it got me 95% of the way there. Not every feature was ported, but it took me another 30 minutes of like filling in the gaps of just saying, hey, you missed this, you missed this. And in 30 minutes, I had ported a 2,000 to 3,000 line application written in Rust of a technology that I also am not. I'm not a Rust pro. I'm a C++ pro over to JavaScript. Like we live in a world now where do programming languages even matter? Like I know it's a hot take, but like, because they do matter, obviously, but do they matter as much? Like I like to say now that my favorite language is the language that is best at being generated by LLMs. If I'm trying to build something, you know, obviously if you have some tech stack where you have to use a certain language, you're sticking with that language. But in this age of personal software, I'm not going to choose a language just because I like it if there's a language out there that's better in terms of code gen for these tools. And this is coming from someone like my whole social media identity, like my YouTube channel is about programming languages. My podcasts are about algorithms and the differences between programming paradigms. Like I care so deeply about this. I would watch the Rich Hickey talks and the Clojure community be about code craft and taking pride in your code. And now I'm having this existential crisis being like, does it even matter? Anyways, it's just food for thought. So at one point this was in Rust, then it was in JavaScript. So we're going to switch to the second part of this talk, which is on array programming. So we're going to go through this pretty quickly. Hopefully this will just pique your interest if you've never heard of array programming languages. So array programming languages, they date back to the 1960s. They started in 1966 when Ken Iverson created APL. It stands for A Programming Language. Back in the 60s, weren't a lot of languages, Fortran, COBOL. And so naming something A Programming Language didn't seem like a crazy idea, didn't age very well. But then since then, there's been a number of other languages. So J was created by Ken Iverson and a guy named Roger Huey in the 1990s, kind of known as APL 2.0, using ASCII characters instead of symbolic systems. And then BQN and WeWa have been created in the last decade and a half, and they are basically derivatives of these. So what we're going to do is we're going to quickly code up a sample problem, sum of squares. So generate the first 5 numbers, square them, sum them. In a functional language, you can do this in a single line, and in array languages, you can do the same thing. Even Python, Java, you can probably do them. It's not a single line, a couple lines. So it's a very trivial, straightforward problem, but it's just to give you an idea of these languages. So first things first, we're going to generate the first 4 numbers. Single symbol. So this is the equivalent of your range in Python or your iota in C++. Pretty awesome. Second thing we're going to do is we are going to square the numbers. So we can multiply, and in order to make this square, we can use a combinator called the W combinator, aka duplicator. So this duplicates the argument twice. So what do you get when you take multiplication and you pass the same argument twice? You get square, which is very nice. And then after that, you can do a plus reduction. So this is the equivalent of a plus fold in, Haskell or any functional language, and you're done. Pretty fantastic. You can obviously see why I love these languages. There's nothing better out there, folks. And so if we want to put this in a function, we can basically just put this in braces, call it something, assign it, and we're good to go. So this is what we call explicit function syntax, but we can make this tacit by basically removing our references to variables. And so if we put this in here, it basically makes it tacit. I don't have time to explain why this works, but just know that it's absolutely awesome. Next up is APL. We're going to see how long this embedded site takes to load. We got to work on that, tryapl.org. So we're going to do the exact same thing. This time, it's going to be iota, is what they call it in APL. So iota 5 gives you 1 to 5. This is 1 index this time. Then we are going to do the multiplication. And we're going to use a, once again, W combinator. They call this self. And then if we take this and do a plus slash, we're going to get the same answer if it were a 0 index language. So plus slash for reduction, square with the self for W combinator for square, and then iota 5. So we're going to keep going on because we got 2 more languages. And so APL is the OG. That's back from the 1960s. This is WeWa. This is the newest of the languages. This is a array language combined with a stack language. So it's going to look a little bit different. And one of the main differences is you'll note that I've just been basically making these symbols appear out of nowhere because there's basically key mapping. So I used a slash with a letter for BQN. I used a backtick and a letter for APL. In WeWa, you can just basically type keywords, and when you hit Control Enter to evaluate, it maps it to the symbols. And a lot of people really love this feature. So if we program this now, we are going to type range. And if we go Control Enter, that maps to the range symbol. So you get 0 to 4. Then we want to do a self and multiply, and that's going to give us the square function. And then once again, we do a slash for the reduction and a plus for our binary operation. And we've got the sum of our first squares of our first 5 numbers. And last but not least is J. This is the APL 2.0 that uses ASCII. So we're going to do this rather quickly. If we do indices, which is I dot, that's going to give us 0 to 4. Then we do the multiplication and the tilde, which is the equivalent of our W combinator. And then once again, we're just going to put a plus slash for our reduction. So you can see that this is similar to the other solutions, but this is all ASCII based. So you don't need any special symbols. There's no special way to input this. So hopefully you guys are enthralled and you're all going to go and check out array languages after this talk. The reason I burn through all that stuff, though, is just to say that there are a number of array languages out there that take a number of different design choices. So all of them, except for J, are symbolic languages. They use Unicode symbols. And if you actually go back, the names of Unicode symbols in the Unicode standards sometimes are the APL iota because they were literally the symbol that came from APL. So kind of cool, bar trivia fact that you can impress your friends with later. Because obviously they'll be impressed by that. So the input method, I mentioned that, for some it's backtick or slash plus a letter. J is just ASCII, so you don't need to worry about it. And for WeWa, it's like a keyword mapping. You type a word, hit a button, and it maps it for you. Ambivalence, this is one of the more confusing things about array languages, is that a lot of these symbols or digraphs in J, they have two different meanings. So the classic one is, the binary version of minus is subtraction, but the unary version is negation. But it gets confusing because for a lot of the symbols, it's not as easy as keeping them in your head as minus and negation are. But WeWa doesn't have this. Every symbol just has one meaning. And I'm not going to get into the 2 trains and 3 trains, but this is just to say that the tacit models differ in the choices where they map these basically composition and juxtaposition of functions to different combinators from combinatory logic. And I bring all this up because what did I want to do with my Blink program? I wanted to create my own custom array language that I could use to basically filter, rank, and build indicators and trend lines. That this is kind of, I think, what's going to be one of the emerging things from LLMs is I don't want to type a language that is verbose now. C++, Java, Python. It takes too long. I can't code at the speed of thought. But with these array languages, with these symbolic languages, I can code at the speed of thought. So that's the only time I actually want to program, is when I'm using these languages to do some very custom specific thing that might be a DSL or might be some embedded thing within another language. And so I've created this thing that I call Blink DSL. We might rename it later, but it's symbolic. It has 2 different ways to input. You can use keywords or you can use the backticks. And it uses something called arity dispatch for its function composition model. I don't have time to get into it in this talk, but it's very, very cool. And if you've got questions afterwards, find me in the hallway track and we can definitely chat. And so we're going to switch back to the Blink program. And now you hit slash, and this brings up a little expression window. So once again, this is entirely vibe coded. This is a DSL that's embedded within this framework. It's going to transpile to 2 different backends. One's interpreted, one's compiled, and then I'm going to use that to basically explore the stocks. And it's just fantastic, without ever having looked at the code. So, the first thing that we can do is the kind of WeWa input method. You go control enter, and that's going to map, div to the division symbol. And I don't like doing that. I just build it because other people in the future might like it. But I prefer the backtick enter mode. So this is basically saying delta. Delta is a function, if you're familiar with any of these languages, and map adjacent is probably the nicest named one in my opinion. It's a function that takes a binary operation and applies it to adjacent elements. So sometimes languages call this pairwise, adjacent difference, zip with next. It's very sad that this has no uniformity. Most languages call reductions, fold or reduce. Most languages called map or filter. This one has absolutely, no naming convention. And this is a website that I built, googletranslate.com. You can type in basically the name of function from a specific language and then get the other named functions across those languages. So useful tool if you ever want to mess around with it. But so I call this delta, because it's, a delta symbol from the Greek alphabet. And it's the same idea. So you're applying division to adjacent elements to get basically the percentage change day to day. And if we, do this on close, so I've got OHLC for open, high, low, close. Usually you get the price differences from the last price of the day. And I hit enter. It's now going to open an expression list on the left hand of the screen. And you can see now that this blue trend line popped up. That is basically the computation of this expression on the current stock that we're looking at. And I can go up and down now to look at the different stocks. This is Apple, this is NVIDIA. Very, very cool. And so the irritating thing, though, is if you actually look, it's hard to tell. Oh, look. It was freezing out for a second. It's hard to tell, but in the very bottom right of the screen, it says expression and the value. And so these are values that are like 0.98, 1.02. But really, we want the percentage. So in order to get the percentage, we can, if this cooperates, hit slash, and then do the same thing. But what we really want to do is we want to do 100 times 1 minus with the C combinator. So we don't actually want 1 minus our value. We want our value minus 1. And so this is the C combinator. It's going to flip the order of the arguments that you pass to your binary operation. And so now if we type in, we can do it the same way, control enter, and then we do the delta and the C. This is going to be the exact same trend line. So you notice if I toggle between these two trend lines, nothing changes because the relative difference between these are the exact same. But if you look at now the values, I don't know why my trend lines are being a little laggy here. You can see maybe down in the right-hand corner that these are now effectively percentages, that correspond to the right thing. So the last thing that we can do, or not the last thing, but what I found when I built this, I've got this tool and I'm like, I've got my magic wand and I'm just like, creating things as I go. It's a little bit irritating when you've got, prefixes of former expressions, but you have to retype the whole thing. So if you hit D, it'll delete the expression, and now if I hit Shift/, it'll bring up a new expression window, but you can basically only type the prefix that you want. And if you hit Enter, this will then connect it with an arrow, and now your full expression is basically chained. And so the reason I bring this up is because if I want to sort, except it doesn't look like it worked. So now we got to go like this, and go like this, and let's delete this. Or actually, we can edit it as well. So why didn't this work? Ooh. The risk of live demos, folks. Let's try it again. 100 multiply 1 minus tilde. So for some reason, this is now, anybody spot the bug? Well, this worked in Melbourne. So, 1 minus. So we'll try this once more. Yeah, it's not. So you see there's a little X in the corner screen, so you can tell. So we actually don't need this, but I was going to build up 3 trains, so 3 basically different expressions that are chained to each other. But we can use this expression. And so if I hit S now, it's basically going to sort all the stocks. Oh, no. Oh, yeah, we need to do this. All right, so we can zoom in, that's fine. Go back here. So if we do last, and hopefully this works at least. So yeah, it looks like this is going to work. So this is basically just taking a single value, and now we hit S. It's basically going to go behind the scenes, compute a ranking of the stocks based on the last percentage change. So at the time when I downloaded a corpus of stocks behind the scenes, the number 1 is Beyond, which is like a 36% jump. Beyond Meat, which is like the Impossible Meat company. Anyways, the idea is, modulo that one little hiccup, which I got to figure out what happened there. You can basically, like, the world's your oyster now. I have a DSL inside of this that I can sort, I can filter, I can do all this stuff, and I've never looked at any of this code, which is just phenomenal. So we're going to skip to the last section of the talk because I'm a little bit low on time and talk about GPU programming. So I mentioned that there's 2 different backends for this DSL. It's built both on BQN, the array language, and a library that was open sourced a couple months ago at NVIDIA called Parrot, which is built on top of Thrust. So the BQN side of things is an interpreted backend. And when you're using this tool and you build this, when you're toggling between the expressions and you're toggling through stocks, it's using the interpreted backend because it's super fast if you just have a little bit of data. But if you have a lot of bit of data and you need to compute this over 10,000 or 5,000 stocks, an interpreted backend is not going to be great. So what happens is these little check marks are for the CUDA backend, the Parrot backend, that is basically generating the code and then compiling it. And so if you get 2 check marks, it means one has been generated and compiled, and the second one is verifying that it has the same output versus the interpreted backend, which is just absurd. Like, I didn't actually think that the models, I was using Gemini 3 at the time, were going to be capable of this. Like, building 2 different backends that, like, as you go on the fly are able to do compilation in the backend and check the 2 backends together. It was just like mind-blowing. So I don't have time to go through like what Parrot looks like, but it's a high-level array language that, or array library that when compared to Thrust and Cub, which are 2 basically existing CUDA libraries that we recommend folks in the CUDA C++ ecosystem use, this one is much, much more high-level, and it implicitly does all of the kernel fusion behind the scenes. So if you want to basically minimize the number of kernels that you're generating when you're using Cub or Thrust, you have to do this all manually using things called fancy iterators. Parrot basically is a high-level abstraction above this that does it all behind the scenes. So in my opinion, Parrot is the best CUDA C++ experience when it comes to targeting GPUs. So this is just a small example of what the kind of code looks like. If you're familiar with Rust iterators, it's kind of inspired by that. You basically just method chain a bunch of stuff. And in this code, even though we're invoking like 8 different methods, there's only 2 kernels launched, one with the reduction at the end of the day and one with the where, which is basically a compaction. So A really, really nice library. Like I said, I don't have more time to talk about it, but if you've got questions, find me after, like I said, in the hallway track, and I'm happy to answer. So this brings us to the summary of the talk. AI coding has redefined, initially this said what I'm capable of, but I replaced it with you. We now live in an age where we have this productivity, force multiplier that it's absurd. Now, what you think you can do with these models is probably below what you can actually do with them. You just have to believe that you can and try. The second point, always try the newest models and tools. I talked about this earlier. The third, summary is that I think in a world where programming is done for us, we don't have to type, these small compact DSLs might have like a resurgence, because that's the only time I actually want to type is when like the typing of it myself is faster than what an LLM could do. The second last point is GPU programming has never been easier than it has been before. That doesn't make it easy. It's still difficult, but with some of these libraries, both on the Python side of things and the CUDA C++ side of things, it's getting a lot more easier. And last but not least, don't think you can, know you can. Like Morpheus said,
Don't think you are. Know you are.
And by the way, this entire slide deck was made with AI, not PowerPoint, not any existing framework. I made it with Cursor. Every single page is just a different HTML file that I asked it, hey, do this, do that. PowerPoint's dead. Gamma's dead. You can do it all with AI. Thank you.